See a few more people coming in. All right, it is time, so let's get started. Who's been to a Puzzlers talk before? Okay, so most of you know the format. So we've rigged today's one with a bit of a data mining problem. There are a few people here who have seen a lot of these before, so if you're smart, you can figure out who keeps getting it right, then keep voting the way they do. There are 2 or 3 that I think are brand new. I've been so enthusiastic about those that I've shown them to some people throughout the conference already, and so I kind of screwed that one up a little bit, so apologies for that. But so here we are, Scala Puzzlers' last talk of the conference. This is meant to be fun, right? We're videoing it all. It'll be sent to your employers. If you get more than 5 wrong, you're fired. No, clearly not, right? So don't be shy. Yeah, if your arms are tired, that's okay. Otherwise, just vote. This is about learning, and it's supposed to be fun. But yeah, ultimately, we're here to get some fun out of it, and then we can all go and have a nice, beautiful, sunny evening out in Amsterdam, and then we'll have you all had a good conference? Everybody enjoyed Scala Days? Yeah. Excellent, excellent. So, well, unfortunately, there's no Nermin today. Nermin, those who know him, he runs the Boston area Scala meetup. He actually emailed me to ask whether I would sell him scalapuzzlers.com because he wanted to do it. That's how we got this whole thing started way back when. He's really busy doing a lot of work, so he won't be here today, unfortunately. For those of you who know Puzzlers, you have about 5 more minutes to relax and chill out because I'm going to do the kind of the rules of the game, how this is going to work. And those who've been here, they know how this works. So just chill out a little bit, enjoy the popcorn. Those of you who have it, there's a little bit left, as I've said. Feel free to come up to the front and grab one if you want some more halfway through. I know Zevia downstairs, they had a popcorn machine as well. So clearly we can have our share of unhealthiness today. So what's a puzzler? Well, the idea behind a puzzler is that it's an intentional language feature. It's not a bug. Sometimes the definition is a bit arguable. I know Adrian, after the session in San Francisco, he said, like, morally he got them all right because they should all be bugs in one sense or another. But this is what I mean by this. This is something against there is no open issue in Scala Lang or in the Scala Jira. It's behaving the way the language at the present time is designed to behave. Some of them are conceptually, clearly, maybe due for some revision. We have a whole roadmap item on the Scala roadmap dedicated to that, but for now I'm safe. It's also not just weird because you don't know Scala, so it's not like, oh, what if we use a backtick in this position and then it's followed by an apostrophe? I have no idea what it does. This is not meant to confuse you by syntax that you've never seen before. In some cases there might be a feature being used that you're not familiar with, but I would hope that a lot of this is all reasonably regular type Scala. So yeah, none of this like weird operator stuff. And the whole point of a puzzler is that it should be surprising or kind of counterintuitive to somebody who's reasonably skilled. In other words, from your mental model perspective, you should think that it will do something and then it will hopefully confuse you by doing something different. Of course, the part of this is what does it mean to be a reasonably skilled Scala developer? That's a different discussion. But in my ideal world, a puzzler is a single command that you are absolutely sure does one thing, and when you run it, it does something else. And that's great because it gives us the opportunity to learn about the language. So, in fact, this is a little bit out of date. I've tested them against the 2.11.16, or 2.11.6 rather, REPL, and you'll see that being used from time to time here. Yes, so you can use the REPL, of course. So what I should say about this as well. So these are all the code that you're going to see is designed to run in a clean REPL. So this is not, there's no other packages involved. You're not in an IDE with some kind of magical functions. If you open the clean REPL and pasted the code in, that's what we're going to be talking about here. You can, of course, do this, but to be perfectly honest, it'll make the whole thing a little bit boring because you'll see the answer. Plus, I will do that for you a couple of seconds after the answer, and then we'll have some fun. To do that, I am going to use a very cool tool made by Mr. Marconi Lana over there called Represent, which is it's an in-REPL presentation thing. And I know there's been some other talks that have used it. You can find it, it's on GitHub. Basically what you do is you load this thing. In Windows it's a bit of a nightmare because it requires ANSI coloring, so I had to use a particular thing. And then you get a really nice kind of DSL, no slide for me, in which you can actually show this kind of stuff. And the nice thing is that it's actually a REPL, so we can run the code and we can do other kinds of stuff. So very cool. And we're going to be using that to go through some of the examples. Sorry, is there a button for the lights? Yes, you're right. We're going to be looking at code. So is there a... Lights off. Ah, thank you. Excellent. Much better. So having said that, we're about to get going, especially before you realize that this image is weirdly flipped and looks kind of creepy. We have some books, we have a few left. We're going to sell them after the talk, and there's going to be a discount code mentioned as well. So just so you know, if you really think this is so great, you want to see all the other ones, come and see me afterwards, or Bill, who's sitting at the front. All right. So the way this is going to work, I'm going to show this. I'm already showing this. It's a sample of code. I'll talk about the code a little bit, and then I'm going to show 4 sample answers, and then I give you some time to think, and I try and dance a little bit. Nermin's much better at this. He's a much quieter kind of guy. I start to make stupid comments and things like that. And then I'll ask from time to time whether we think we're good, and then at some point we're going to stop with the thinking, and then we're going to vote, and then we're going to see who gets things right, and then I will explain them. Feel free to work in teams. That's part of the fun. So what's going on here? We have an object called xy. Really blurry screen thing. I'm sorry about that. Can you see the code at the back okay? Yeah? Okay, excellent. I would say come to the front, but unfortunately there's not much more space. So within that object, we have 2 other objects, x and y, and they both declare a value. And those 2 values are recursive, or they're mutually recursive. So x.value refers to y.value, and y.value refers to x.value. And what we then do is, based on a 50-50 chance, we either print xy.x.value, or we print xy.y.value. So far, so reasonably simple, hopefully. Here's your choices. A, prints 1. B, prints 2, by which I mean it will always print 1 or 2. C, prints either 1 or 2. D, throws a runtime exception. Off you go. Wow, this is really pair programming. Ooh. Okay, 20 more seconds. All right. Okay, let's have a look. Who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? We have about 200 people in the room, because some people seem to have voted like 4 times, but that's a smart move, then you definitely get it right. Well, let's have a look at what actually happens. So, no slide for me. Yes, I want a slide. And now we are going to go run. And it goes 2. And we're going to go run again. And it goes 2 again. In fact, I probably should go back and go again and run it again. And so you see it prints 2. So it always prints 2. So the answer is B. Woo! For those of you who got it right. So, now the question why this happens. And this is actually kind of interesting. And in San Francisco, somebody said, well, what happens if you do this on Scala.js? And it's JavaScript, so it probably prints an array or something like that. Who knows? But you'll see why, because this actually makes use of some sort of very interesting JVM level stuff. Because if you try to simulate what is, or replace object anyway here with class or lazy val or something like that, and actually the spec explicitly says objects can be thought of as a kind of lazy val, then you get D. You get a Stack Overflow because it keeps trying to mutually refer to each other. What's happening here, though, is pretty interesting. So what happens is, well, randomly, of course, we decide to initialize either one or the other. So let's assume we go in the first branch and we try to initialize xy.x.value. So we get into xy.x.value, and the first thing we do, so it realizes it has to initialize object x. It starts doing that. It starts to initialize value, and then it realizes it needs y.value, so it calls y, starts to initialize y. This is in the static initializer for that thing, and then it's trying to do y.value, and then it reaches x, and what it does at that point is it tries to initialize class x again, and now we get to the JVM specification, which says you cannot initialize a class more than once. Class initialization is not reentrant in that sense. So what the JVM does is it returns x's value uninitialized, like the default, 0. So it doesn't create an endless loop. And this is really a JVM spec level thing. So we're now in y.value, and it gets back x.value to be 0. It doesn't wait for that to be finished. So it makes y.value 1. At that point, the call to y.value in x completes. By this point, I've totally lost everyone because it's hard to get your head around this. But basically, y.value completes being 1 at this point, and in other words, x.value then becomes 2. If we go down the other branch, the same thing happens, but in the inverse order. The first one to be initialized always gets the value 2, and the other one always gets the value 1. And indeed, if we swap any of these things, if we make them lazy vals or something, we will get stack overflows. So there's an interesting thing. This is very JVM dependent. That's what I said. I don't know actually what happens on Scala.js and how they handle that, because this really relies on initialization behavior of the JVM. Let me see whether, do I have a slide that tries to do this with, let me see, do I have a slide that tries to do this with, no, I don't. Anyway, never mind, I'll add that for the next one. All right, that was the first one, excellent. The next one, well, in this case. So what do we have here? We have a playroom, and in the playroom we have a toy class, it's a case class. And it has a single parameter, which is the squeak. It's like a squeaky toy, like, you know, and so you have to program it with a message. And the message defaults to, so as a default argument, this .toString, and you override it with a squeeze message. So the idea being that if you wanted to, you could pass it a different toString, but if you don't, it'll go get the default. And then we import the playroom, so we have this toy thing in scope. And then we make two toys. We do two comparisons. We make two toys with a specific squeeze message, and then we make two toys with no squeeze message. And we try to compare them, or print the result of comparing them. Here are your 4 choices. A, fails to compile. B, prints true, false. C, prints true, true. I don't need to read that so slowly. D, the first one prints true, and the second one throws an exception. Fails to compile, just as some hints about this. Well, you might wonder, for instance, if you look at the definition of toy, in the default argument, it's referring to this .toString. So anyway, those are your 4 choices. Here we go. Sorry. One thing I should say, I'm sorry to interrupt you, but one thing I should say is something I forgot to mention in the explanation. Look at how we're making the two instances of toy, right? One is using the case class constructor, and the other is explicitly calling new. I should point that out. I forgot that. Sorry. Okay, 20 seconds. All right, everyone. Let's have a vote. Who thinks it's A? Fails to compile. It's a few of you. Who thinks it's B? A whole bunch. Who thinks it's 3? C, rather, 3. C, Prince True True. Who thinks it's D? A whole bunch. So, let's have a look. So, most of you got this right. Excellent. Yeah, thank you very much. So, let's try to figure out what's actually going on here. Well, what's going on here becomes a little clearer. This is the nice thing about REPL Zen. I can actually now do one of this. Let's go new toy hello. Right? Now that makes sense, right? And let's do this. Oh, goodness, good point. Yes, sorry. Yes, this is tiny, isn't it? Properties, font, make it bigger. Oh, no, that looks ugly. Is that better? All right, so now that's toy. Whoa, look at that. That's okay. And now let's go toy. Huh? Weird, huh? So I know, and I tend to agree with Miles. I think this is a bug, but it's not necessary. I don't see where in the spec this is wrong, because there is some magic that's going on here. This is, as you can imagine, this is really to do about case classes and in the way case classes are initialized. And as I kind of hinted, the key to this particular puzzler is this this.toString reference. The point is, what does the this actually refer to? Now, if you use a this in a method definition, which is the case for all the standard generated things like the copy method, it refers to the object or class itself. But here it's used in a constructor. And in that case, it does not refer to the object or class being created. So the this here doesn't refer to toy, but it refers to whatever this object is in scope. And the thing here is that when you're calling toy down at the bottom here, the method is actually called inside the companion object, object toy. So in some sense, what you can imagine the compiler doing is kind of copy-pasting this line, squeeze messages, this.toString, into the apply method of the companion object. So when it does the this resolution, the this points to toy, which is the companion object. You just don't see any of that. Which is why, when we go back here, if you try to invoke toy down there, you get that weird reference. And because, of course, this is a case class, any property that you pass in, including squeeze message, is part of the equals comparison. So by default now, these two case classes are not equal because they have different squeeze messages. This probably makes sense. But yeah, if you obviously override this by using hello, then they look the same. So that's why the one prints true and the other prints false. B was correct. Here's the next one. So just to finish with another learning point, some of the generated code in the companion class in toy or companion object that's generated does some weird stuff around class loading with this to make this work in the copy method, but it doesn't work for the apply for the constructor. All right, next one. This is a little bit longer. So let's talk about what's going on here. So we have a method, divide then square root, which tries to do two things with a couple of integers. It first tries to do a division, And then it says, well, okay, if the value is smaller than 0, then we have a problem because we can't take the square root of a negative number, so we want to return a failure. Otherwise, we return a success of the square root of that particular value. Let's have a look. Once we've done that, we will map that out. We will take whatever's in this try that's come back, and then we will print a nice line showing that the square root of n divided by d is this particular value. And then we try to call that twice. So this is chaining tries and then getting the result out. We try to call it twice. Once 18 divided by 2 and then the square root, and then 18 divided by minus 2 and then the square root. And we're out of space on this one, so I'll go back and forth a little bit so you can have a look at the choices. The first one is that it prints the success, the wrapping thing. Square root of 18 divided by 2 is 3.0. And then the second one is a success of Java-Lang arithmetic exception, square root of a negative number. The second one is it prints success of square root blah, 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 failure, because it didn't work that second time. And the second one is it prints success, 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 failure. The last one, it prints success, success, and then the exception. So if you look at it, you'll see that the difference largely is what the wrapper is, whether it's success or failure that's coming back here in both cases, and then how it's handling the value that's inside, whether the value is plain or whether the value is wrapped somehow. So let me go back and show you that code again. We try to divide n by d, and then we map whatever comes out of that, which is going to be a success or a failure. We pull that out, we take the value. If it's less than 0, we get a failure. And, sorry, n by d is, yeah. So we're not dividing by 0 here in general, so we're going to get it out. Otherwise, we try to do the square rooting. And then once we've done the second success or failure, then we get out we get the value and we print it. So let me show you the options again. All right, 20 more seconds. Okay. This one isn't so great because we have to flip back and forth. I'll see if I can fix that for next time. So who thinks it's A? Success, success. Well, one brave soul. Who thinks it's B? Success, failure. Oh, there's a few of you. Who thinks it's C? Oh my goodness. Who thinks it's D? There's a few, yeah. So, well, we have an overwhelming choice by popular demand. Let's see how 95% of the population of the room did. Let's try it out. Run. Success, success, failure. I think, let's have a look. I think most everybody got that one right, which is excellent. The answer is in fact C, so give yourself a round of applause. Okay. So, I mean, I'm guessing that most of the people, well, maybe you just chose the weirdest answer. That's the problem with puzzles, like the obvious one isn't the right answer. But the thing here is really the chaining has gone a little bit wrong. Right? If you were to write this as a for comprehension, you would see why. The problem here is that instead of doing what you think it's doing, namely successively chaining tries and failures, you are calling map and not flat map in the middle one. Most of you seem to have spotted that, which is great. But what that means, so let me just go one slide forward, where we are actually calling flat map. So this behaves the way you would expect it to. It succeeds and then fails. But the problem is that the other one actually compiles perfectly fine. What happens here is that the first one will give you a success, and that will then you map over that, which will take that and map it, and then you get you either get a success of a failure or a success of a success, and then you kind of print it out, and you pull that out again. So the thing that you're pulling out of the value is not actually the value inside the try, but it's a success or a failure object itself, and that is not what you want. So if I just run this again, you see you get the outer wrapper. It's always a success because you always get to the second stage, and then it pulls the success or failure out of the middle one, and it doesn't abort. So the way to think about this is, remember that if you are trying to do your chaining properly, use flat map for all the middle ones. And this can be a little tricky when you start to add things when you chain. I mean, the way you probably wouldn't write this initially like this, but what you may do is you may just do the original mapping, and then you may decide to add another map later, and you have to remember to use flat map for the ones in the middle then. What you may also want to do is to use a for comprehension syntax, because that does this for you kind of automatically, which would be a bit nicer. Huh? Or use a type annotation, yeah, of course. So this is, yeah, absolutely. This is a little, if you put divide then square root with a, thanks Marconi, if you put divide then square root with an expected result type, which would be, try, or a string in this case, then you wouldn't have this problem, because the thing that's inside it is actually a little weirder. Oh, let's do it. That's why we have this REPL, isn't it cool? Divide then square root, 5. Oh no, I can't spell anymore. It's all this nervousness. Thank you very much for spelling that. Yeah, so that works, because the first one bombs out straight away. That map never ever goes anywhere. But in case that succeeds, then the second map is the one that causes the problem. All right. Yeah, well, this one is constructed a little bit so that the second thing is a string. But in general, of course, if you have the return type annotation on what you expect to come out of the last one, then unless we do this nice example to make it a string in the middle, typically that will catch the issue, which I think is what you were getting at, Marconi. I guess, yeah, be safe with return types. But thanks for pointing that out. Right. Next one. So partial oddity. What is happening here? We have two. So for those of you not familiar, or else in the bottom, I'll talk about that a bit, but we're defining two partial functions here, is even, is odd. And the first one triggers only on the case that n mod 2 is 0, so it's even. The second one triggers on the case that n mod 2 is odd, or 1, so it's odd. And then we take a sequence, 0 and 2, and we map it to this compound partial function. The or else basically says, take the first one, try to apply that. If it's not applicable, try the next one. And then we do the same thing again for the sequence of 0, 1, and 2. So a sequence that actually has an odd number in it. Let's have a look at what the options are. The result is even, even, and then even, even, even. So yeah, 0, 1 and 0, 1, 2 are the numbers, and the other one is even, 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 odd, even. Thirdly, prints 0, 2, and 0, 1, 2. And then fourth option, first statement prints list even, even, and the second throws a runtime exception. Let's have a look at that code again. So here's the code. Define is even, define is odd, and then you go sequence 0, 2 map if is even, else is odd, and similarly for 0, 1, and 2. There's your options again. Here we go. I'm going to have to speed this up a bit, otherwise we'll never get through all our puzzlers, but let's have it 15 more seconds. All right, let's look at the code one more time. See this? Here's what we do. Who thinks it's A? Even, even, even. Who thinks it's B? Even, odd, even. Who thinks it's C? A few people. Who thinks it's D? A bunch of people. Who has no idea what to think? No. Okay, so let's have a look at what happens here. Who just picked the weirdest one? All right, so here that's the one where I did it with flat map, so let's skip that. We don't need that anymore. Oh, what was that? Oh, here was the for comprehension. Had some nice examples. All right, so here's the partial oddity. Let's give it a try. Run. Wow. So, okay, good that you guessed. Now you can explain it. No, so let me explain what's going on here. The match error one is kind of interesting here because, why? What on earth is going on here actually? So the thing is that this all looks perfectly, reasonably normal, and I think we've all defined things this way. The key to this puzzler is that thing we're defining. Sorry, let me say this. The thing we're defining here is not actually the partial function that you think it is, I would guess. Because the real partial function that you think you were defining looks like this. You define the val, then you give it a type of partial function, and then you give it the function body. What we have here looks confusingly similar, but it's actually something very different. Well, it's close. What we have here is an application of the apply method on partial function, on the partial function object. And what you're giving it is you're giving it the body of the apply, but what doesn't happen is that the isDefinedAt method is generated along the same lines. So what you're getting from isEven is something that is a partial function, all right, which has this particular body, but it's defined everywhere. And so what happens when you run it is, for the first case, it's perfectly okay because you never need it. For the second one, what happens is that it decides that it's applicable for 1, enters the body, and then it can't find a case that matches 1, and then it goes bang, which is why, oh, no, that's the wrong slide. which is why when we run it, it gives you this match error 1 of class Java-lang integer. If we define them properly, as you would imagine, you get what we would expect. It just prints out even, even, and even, odd, even. So the gotcha here is, remember how to define partial functions. Don't do it the way I just showed you, because it has very weird consequences. Next one. Okay, we're really got this. So this one here, what do we have? We have an object, and it contains 4 methods. Both are 2 overloaded pairs. And the difference between the overloaded pairs is that they differ in the number of arguments. The first one takes a unit and says I accept a unit, and the second one takes a unit and nothing for A and says I accept a unit and nothing. And then for B, we have one that takes a unit and the second one that takes nothing. Notice that unit and nothing are totally disjoint types here, right? There's no type that meets both requirements. And then what we try to do is we print O overload A 99 and B O overload A, B 99. Notice also that 99 is an int, of course. And here's your choices. The first statement prints I accept a unit, and the second fails to compile. The first statement fails to compile, and the second prints I accept nothing. Both statements fail to compile, and they both print I accept a unit. Here's that code again. We have the object. We have 2 pairs of overloaded methods. They look pretty similar, except for the number of arguments. And then we try to call each one with the argument 99. Here's your choices. Let's go. I'll go back to the code in a bit. So. I'm going to get brutally quick here, because otherwise we're going to run out of time. No, keep going, about 15 more seconds. All right, let's have a vote. Who thinks it's A? First statement prints I accept a unit, the second fails to compile. Who thinks it's B? The first statement fails to compile, the second print. Who thinks it's C? Both statements fail to compile. Who thinks it's D? Print I accept a unit. All right, let's check it out. Here it is. Run. So, it is indeed true that the second one fails to compile. And now I think I have a version where I've commented out the second one, so let's see what happens to the first one. The first one prints I accept a unit, which means that the answer is A. So one person got it right. Excellent. Whoa. So, all right. Now, what on earth is going on here? So let's briefly explain this. I don't think I'll have time to explain it as much as I would like. Really what's happening here is that the compiler, when it tries to figure out, for both of these cases, it has to figure out which of the overloaded methods to use. And it uses overloading resolution, it's the algorithm defined to do that. And obviously what it finds is that, well, there's no int method, so there's no obvious candidate. But the first thing it does when it does overload resolution, and this is a shortcut, is it does something called shape matching. It basically sees whether there is an overloaded method that has the correct number of arguments, because clearly if it has the wrong number of arguments, it's never going to work. What happens in the first case is that it identifies one overloaded method that has the right number of arguments, namely the first one. But it's a unit and not an int. And then an implicit conversion comes into play, not an implicit, the thing you know about, but something the compiler is allowed to do to make types fit basically you can make anything a unit. That's a rule called value discarding. And so it says, all right, I'm going to turn this into a unit for you then. It doesn't, you'll get a warning. It says, are you sure you mean this? But it basically can identify one that fits. Now that works in the first case, and that's why it prints I accept a unit. What happens in the second case is a bit more interesting. What happens in the second case is that because there are two options available that both take one argument, it can't figure out based on the shape which one is the one to choose. And the point about this value discarding rule that turns anything into a unit is only possible once the compiler knows that it's really a unit that you need. But in the second case, it doesn't know that yet because it hasn't figured out which method it's actually going to pick. And that's why it tells you, I can't figure out which method to call. The reason this is interesting and a little bit weird is that it's dangerous if you're writing a library, because what we've done here is we've taken code. So imagine that in the second case, the second method didn't exist yet. Then your code would compile perfectly fine. And then you as a library designer decide to add an overloaded method. You obviously take care to ensure that the types are disjoint. So you would imagine that there's never any chance of them conflicting, like you take an int and a string or something like that. And yet, adding an overloaded method with disjoint types can break your client's code. Because if they have the same shape, you can invalidate some of the compiler's magic implicit conversions that it can use. Not just value discarding, there's a few others that it can use. And there's really no good way around this as far as I'm concerned beyond saying, well, be careful when you use overloaded methods that have the same number of arguments. All right. Let's have a look. What's the time? Well, given the time, I'm going to skip forward and do a couple of others later. Oh, no, this is one. This is all right, think of a card. So, think of one card. So this is where we'll do two more if we can make it. We'll stay a little over. What do we have here? We have a case class. It takes an int as a number. It's a card deck. And it has a default suit. If you don't give it a suit, it'll be a clubs card. And then it takes that number and it turns it into a valid number if you give it like the wrong value. So it converts it into a number between 1 and 13. And it has an implicit a method that takes an implicit argument, which is like the deck. This is sort of your scope, if you like, the current cards that are available, and it checks whether the deck or the card is in the deck. And then what we do is you don't want to always have to make card objects all the time because you've got a default suit. So you want to be able to treat numbers as cards objects. So we define this implicit int to card, which takes an int and turns it into a card. And we also need to work with a deck, a particular scope. So we define a set of cards that we're working with, which is a list, which contains a single card, which is the one of clubs. And then we ask, what happens when you print 1 is in deck? Here are the choices. A throws a runtime exception. B prints false. C prints true. D fails to compile. I'll give you 20 more seconds, because we're getting short on time. Okay. Who thinks it's A? There's a runtime exception. Brave souls. Who thinks it's B? Prints false. Who thinks it's C? Prints true. Who thinks it's D? Fails to compile. Some people are scared or tired arms. Let's have a look what this does. Next, I'm gonna. Marconi will remind me what the syntax is because you can skip a few ahead here. I think it's, huh? Oh, the number and then forward, but we're already here. So let's run it. Index out of bounds exception. Huh? Yeah, this is always a good one to end up on. So what is going on here? Huh? Looks pretty straightforward stuff, right? So the answer is indeed throws a runtime exception. So the nice thing about this is the short answer is very simple. The short answer is you are not getting the implicit conversion that you think. Why not? Well, what happens when you get to the line println 1.isInDec is the compiler can't call isInDec on 1, so it needs to figure out how to convert it to a card, which is kind of obvious. And what it does is it looks for something in scope that can convert an int to a card. Now, list is a function of int to card. So that's the first part. The second part is that for some reason that is vaguely undefined in the spec, but not against the spec, if you have a val and an indef that both have the same conversion, it'll pick the val over the def. That's only true for implicits. It's not true for others. You get an ambiguous implicit clash. So what's happening here is that it basically is calling dec of 1 dot is in dec, and of course there is only one element in the dec, so dec of 1 prints an index out of bound exception. Isn't that nice? If you, that's pretty fun, right? If you actually call the implicit that you would imagine is being called, then you get what you would imagine, and then of course, as you know, if we do dec 1 dot, is in dec, then we get what we saw. All right, that was fun. So let's do one more. This one, nice and simple. Some of you might recognize this if you follow Paul Phillips avidly, because I think it's a great puzzler. The branch not taken. So we have a constant basically deciding whether to use numeric or sort of high precision numbers or not. And then what we do is we have two statements. If we're using floats, the value should be 5.0 as a float. Otherwise, it's a character 5. And if we're not using floats, then for some optimization reason, we decide to pull it out into a val, and then we print the val instead. Here's your choices. It prints 5 and 53.0, B prints 5.5, C prints 5.0, 5.0, D, the first statement prints 5 and the second fails to compile. I am over time, by the way, so if you need to go and run for something or so, then please feel free. It's no big deal. Okay, looking at the time, I might want to squeeze in one more. Who thinks it's A? A bunch of people. Who thinks it's B? Who thinks it's C? Who thinks it's D? Most people are tired. It's all good. Let's have a look. I think the majority kind of got this right. Use floats. Oh, yeah, well, sometimes with puzzles, the best thing to do is just to pick the weirdest looking answer. There's always a good chance of getting it one right. So what is going on here? Well, what's going on here is actually weird, but quite simple, really. There's two things happening here. One is the Scala, if you have an if, the Scala compiler can do some smart stuff. If both sides of the branch return a numeric type, that it will try to pick like the sort of upper bounded type. And in the first case, it doesn't need to do that, ironically enough, because println takes an any, so there's no need to do all of this expensive stuff. So you just, pass it an any, which is fine, and of course we're going down the second part of the branch, so it passes the character 5, and that's what you get printed. In the second case, because you're assigning it to a val, the compiler has to try to figure out what the type of that val should be. If you actually force it to be an any, you get the same result. But if you leave it like this, the compiler will go down both branches of the if, and it'll figure out that you have a float on one side and you have a car on the other side. Now, a car is a numeric type. And so it says that the type of x is a float. Okay, once it's decided that the type of x is a float, then you have to figure out what is the value of the car 5 as a float. What's the ASCII character for 5? Which is 53, and of course it's a float, so it has to convert that into 53.0, and that's when you print it, you get 53.0. Do you want to do one more? Yes. All right, let's do one more. So we'll see. Applied values, the last one. So this is another weird one that some of you know because I showed it to you in my enthusiasm. You have an object called the answer, which has an apply, which is a function that returns 42. So it's an anonymous function, returns 42. And then you have, of course, it has to be 42. Then we have a slightly variable one called the variable answer, which gives you two choices. You can either have the same apply, which returns 42, or you can have a def, which takes one parameter, an integer, and it's that many times 42. And then you create that object, or one of each. And so here's your choices. The first invocation prints 42, and the second fails to compile. They both print 42. The first fails to compile, and the second prints 42. And the third is prints 40, last one is prints 42 and 0. Here you go. Okay, go, run. Okay, I know we have the panel session coming up after this, so let me stop it right here. Well, I'll give you 10 more seconds. Come on, this is a bit unfair. This is quite a complicated one. All right, who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? Well, there's an even spread around the room. Let's have a look. All right, so the first one doesn't compile. Let's have a look at the second one. The second one prints 42, which means that your answer is C. Congratulations to all those. So why? What is going on here? Well, ooh, this is fun. So the reason for this is the rules around apply insertion. So the Scala spec says that, if you try to invoke something that doesn't actually, isn't a function itself, then the Scala compiler will try to insert an apply method at that particular point. By the way, one thing I should point out here, that even for the first one, so let me just go back. I can't run this now. Sorry, I can go to the second one. If I run this, and if I go the answer.apply, it does work. Right? So it looks like it should work. So the thing that's happening here, apply insertion. Well, apply insertion, if you look at the spec, only works if you have a method. Basically something that needs a parameter, has a parameter list. Now the val apply doesn't have a parameter list. So it's actually not eligible for apply insertion, which is why when you try to invoke it on the answer, it doesn't work. Now, but then the question is, why on earth does the second one work? Because it should have the same problem, right? Well, the reason it works is back to a little bit to the same thing that we were talking about with the overloaded methods. The way the compiler is implemented, and this is arguably, again, a bug to some extent, it should be consistent one way or the other. What it does is it looks through all the available apply methods and goes, oh, there is some apply method with parens, great. We don't know which one it is, but we can do apply insertion, excellent. So then it goes down this code path that says apply insertion is possible, but it can't pick the second one because that requires an argument. So it goes, well, do we have something that's a function that takes no arguments and does something? Oh, we do, great. So it actually picks the first one, and then it invokes it. And that's why the answer is 42. Right, thank you very much. As I mentioned, if you don't want to pick up one up here, there's also an ebook version. You can get a discount code. I think it's 40% off, whatever. More importantly, Scala Puzzlers wasn't invented by me. I just maintain the domain and try to make sure I pay my bills so that the site doesn't go down. It's a community repo. All of you have run into weird stuff in Scala. You can submit pull requests and we'll tidy them up, and if they're there, you'll be on the next one. Thank you very much. Curly fries. That's the Scala logo. That was what my girlfriend's dad said when we showed her the Scala logo. He said, oh, looks like a curly fry. So I thought we should call this Scala curly fries.